All right, guys, so we're finishing up the lesson from yesterday. What we talked about yesterday was our three different properties of logarithms. We had our product property. That told us that if we have two things being multiplied together inside a log, we can expand it to be the sum of two logs. We had our quotient property that told us that if we have a division inside of a logarithm, we can rewrite it as subtraction. And our power property told us that if we have a term to a power inside the logarithm, we can take that power, that exponent, and move it to the front. And we worked through going through expanding, taking it from one logarithm to multiple, and also condensing from multiple to one. Then we went through going through how to use these properties of logarithms to evaluate, and I think we got through all three of these here. And it brings us to the last piece, and that's the change of base formula. Now, the change of base formula is nice, especially for evaluating or finding the value of these logarithms. Because we know the graphing calculator is able to find the value of a log with any base. But our normal calculators, these 30xs, the log button is base 10. It's our common logs. And if we want to use it or natural log, we need it in that form. We can't just type in log base 3 of 8 into the calculator. It won't give us the value that we want, because the base is not 10, it's not in a common log. So what we have is something called the change of base formula. Change of base formula lets us rewrite any base, change the base of any of these logarithms to be whatever the base we want. Now normally we're going to have this base be 10, be a common log. So what we can say for our change of base is log base b of a is equal to log of a over log of b. Or in our case, they use c. Log base c of a is equal to log base b of a over log base b of c. We could also do the same thing with natural logs, because all we're doing is changing the base to e. ln of what's inside, or log of what's inside, over log of the base. So if we look at this one here, log base 3 of 8, if I want to rewrite this using the change of base, we have log on top and bottom. Log of what we have on top would be log of 8 over log of the base, which would be log of 3. Now, we normally set the base to be 10 because it's nicer to work with common logs. It's base 10. But we get this here. Questions on this here? Now, the nice thing with this is now we can grab the 30xs and say log of 8 over log of 3. And it tells us it's 1.8928. And that's it. Now the graphing calculators would let us take log base 3 of 8. But to do that again, we'd go math, scroll up to log base 3 of 8, and we get the exact same thing. It's a little bit nicer, a little bit quicker to use the change of base, be able to change it from log base 3 of 8 to just log of 8 divided by log of 3, and we can plug that in. Questions on the first one? Let's look at the second one. Log base 7 of 11. So if we use the change of base formula, we'd have what on top? Log of what? 11 over log of 7. Log of 11 over log of 7. And if we evaluate this here, we can just grab the calculator, say log of 11 over log of 7, 1.2323. Because we're going to normally round to the 4th decimal place. Questions on how we did this here? This time, we want to evaluate it using natural logs. So instead of having log on top and bottom log, we're going to have ln, our natural log. What do y'all think the number on top inside that log is going to be? 24, and the number on bottom is 6. So log base 6 of 24 is the same as the natural log of 24 over the natural log of 6. Because again, the change of base says we can change that base to be whatever we want. All we've done for this here is change that base to be e. And since it's e, we use ln. So we'd have ln of 24 over ln of 6. We get this here. Now, if we'd have used log, we'd have log of 24 over log of 6. Well, yeah. Okay, we got that. Let's try again. Log of 24 over log of 6. We get the exact same answer. It is the same thing, 1.7737. Questions on this here? So our log base 2 of 19 would be the natural log of 19 over the natural log of 2. $4.2479. Questions? Because the natural log and the logarithmic of it are going to give us the same value. Because the only time it would make a difference is if it asks not so much to evaluate it, it just asks you to use the change of base to write it as common logs or natural logs. Because here it's more focused on us to evaluate it using it. But if it asks us just to write it in natural logs or common logs based off the change of base, then it would be that. Evaluating, it's just wanting the value. So really, you could use the graphing calculators, do log base and find it. But I think it's a little bit nicer to just change the base and type it in with the 30x says. But that's it.